Today we're going to be talking about alternating current and direct current. So this is where we get our AC, DC. So alternating current stands for AC, direct current stands for DC. All right, there are two types of current that we use in our household every day, and that's alternating current, which is the AC, and direct current, which is the DC. Okay, so what is alternating current? Alternating current, what does it do? It alternates the current, meaning it alternates where those electrons are moving, okay, because the current is the electrons. So what happens with alternating current is the electrons flow back and forth 60 times per second. So you'll have an electron and it'll go this way, and then it'll go back this way, and then it'll go back this way, and it'll go back that way, and it does that 60 times in 1 second. So our light bulbs actually use alternating current. So if you were to do a slow-mo video, you could actually see them constantly flicker on and off. Our eyes are just not sensitive enough to actually realize that it's flicking on and off. When we look up at a light, it looks like it's constantly on, but if you do a very slow-mo video, you can actually see that it goes off and on, off and on, off and on. It's a very slight flickering. This is what every business and household or residence have. As if you plug anything into the wall, you are using that plug in the wall, or the outlet is using alternating current. So alternating current is by far and away the most one that we use in our everyday lives. Okay. Then you have direct current. Direct current is where the electrons travel in one path. So they literally will go from start A to start B, or to the ending point, back to point A, in one constant path. Okay, it maintains a constant value, and its intensity may change, but the direction is always the same. So it will always be going, let's say, in this route. Okay, and this electron starts at A, it goes through the whole route, and it ends at A. Okay, what is an example of this? Anything that uses a battery or photovoltaic cells. Photovoltaic cells are solar panels. Not those huge ones, but you can think of like little ones if you have a little solar panel. They could be big ones too. But anything that uses your batteries. So you're talking for direct current, you're talking about your cell phone, you are talking about a laptop, you are talking about anything that uses a batteries uses direct current. The problem is that it's very expensive to use direct current, and it's impractical over a long distance. So if you wanted a power plant if you wanted direct current into your house, every power plant, you would need a power plant within a mile of your house in order to use direct current. So let's try to draw what the electrons would be doing in the following circuit. So direct current, we'd go here, and then it 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 goes through the resistor, and then it keeps going, right? So this same one keeps going through all the way, okay? In alternating current, we've got one here, we've got one, and then it moves there. And then it moves back to here, and then moves back to here. Now with that one, you also have, like, say, another electron, okay? And it goes there, and then goes there, and then it goes there, and then this goes there. So it just like bounces back and forth in almost the same spot, right? Okay, so this is another drawing of what I was trying to show. So in a wire, if you had direct current, what you notice is that all the electrons are going in this one direction, whereas alternating goes one way, then it goes the other, then it goes the other way, then it goes the other. Okay, but if you look at this electron, it will go all the way to the end. If you look at this electron down here, it will only go from this position to this position and keep bouncing off back and forth. Okay, so which one do we use today? Well, we actually use both. AC is used in every house and business. Those are the ones that we have in an outlet. DC is used for anything that has batteries. So you're talking about cell phones, things like that. If you ever look at a laptop and you have you have it plugged into the wall outlet is AC, and you need a converter or an adapter that's that big box that's actually in the middle of your cord that changes it to DC. You can't go directly from an AC outlet into a DC product. You actually need an adapter or converter in order to do this, otherwise you'd fry it. All right, so why do we use alternating current? Well, it's used by the electric companies because you can increase the voltage and decrease the voltage throughout the entire time. What does that help you? It helps you become more efficient, so you don't need to be that 1 mile away. And it also helps reduce the resistance along long distances. So one problem with electricity is that it actually loses some of its energy from the start of the power plant to your house due to resistance. And so if you can limit that by increasing your voltage, then what can happen is that you lose out on resistance, and therefore you don't have to worry about losing as much energy from point A of the power plant to your house. If you use direct current, it loses it, and you end up with a lot less as it goes throughout, as it goes from point A for the power plant to your house. Okay, so this is the process that we use because we use alternating current. So first off, it leaves the power plant. Okay, so you leave the power plant, it's leaving it at a high current rate, and it goes, and what happens is that the power plant, which is a few thousand volts, you have a transformer. What it does, this transformer, is it steps it up. Okay, what does step it up? It means it makes the voltage even higher. Okay, so it steps it up to several hundred thousand. So then they go through these high voltage ones. And then when you need to, you can't put, as this says, 400,000 volts directly into your home. So what you need to do is you need to also step it down. Okay, and you'll do this a few times. So you'll notice here's another transformer step down right before it gets into your house at 110 volts is what this one says. I believe we also use 220 and 240 sometimes, depending. But so you step it up. So then it's extremely high voltage, meaning your resistance is down. And then when you're about to use it, what you'll do is you'll step it down, and then you'll use these more, these ones, and then you will step it down even more to get it into your house. So the reason, once again, is you step it up so that you lose that resistance, so you're not losing as much energy in the transportation of this of the electricity, and then you step it down when you're about to use it in your house, because you cannot use 400,000 volts in your house. Okay, and so that's what happens. That's what this part is this is the first step down. It goes down to 7,200 volts, and then what you do is you step it down again to 240, 110, or 220, and then that uses these boxes, which are the transformers. Okay, so you step up using transformers and you step down using transformers. All right, so then you've got all the electricity that goes into your house, and it's connected to a circuit breaker. If you don't know where your circuit breaker is, please go ask your parents or your guardians where your circuit breaker is. It's extremely important to know. Why? Because if you ever have some electrical fire or anything going off or haywire, you run down and you turn on the circuit breaker, which cuts off all electricity immediately to that location. If you don't know exactly which one, because there's a lot of different circuit breakers, know where the main circuit breaker is and flip that one so that it turns off all the electricity to your entire house, and then you can figure out where the problem area is a little bit later. Okay, but how does a circuit breaker work? What happens is that normally the switch is closed, which allows the current to flow. So you're talking about like just a normal, it's not like a light switch, but think of a light switch. So the light switch is normally on, okay, for this circuit breaker. So it allows the electricity to flow from the outside into your house. If the current gets too hot, what happens is the switch heats up, and at a certain temperature, the switch will actually open up, which means close it, and then it stops the current from flowing. Okay, and because it does this, because it's heat sensitive, there's actually no damage to the actual system. So once it cools down or you figure out the problem, you can turn it back on. Okay, so once again, it flips off to actually close off this circuit to make sure that you can't actually run it. All right, so let's explain the process described below. First off, this is their power plant. Okay, it produces electricity with a few thousand volts. And then so what happens is that you step it up immediately. You step it up to these high voltage ones. Okay, and then it runs at a high voltage. Why? So that you can reduce the resistance that you're going to be encountering. And then what happens is when you want to get to your house, you step it down, and then you will probably step it down one more time, and these are done through transformers, to be able to get it safely into your house at 240 volts, 220 volts, and then sometimes it's 110, just depending on the outlet and stuff like that. And so that's what you're ending up doing is you're trying to step it up, and then you step it down. Okay, and this guy, this whole process right here uses alternating current, which is where those electrons move back and forth, right? All right, hopefully you have a basic understanding of the electric process, and have a great evening.